energy levels in hydrogen atom. To analyze the energy levels in hydrogen atom, according to Bohr, the energy of electron in the nth orbit, that expression if you consider, that is En equals to minus m e power 4 by 8 n square h square epsilon naught square. So here if you substitute all constant values other than n square, so that is principal quantum number, so then you will get the expression like this: En equals to minus 13.6 by n square electron volt. Now here instead of n, if you write 1, 2, 3 and so on, you will get the energies of different orbits in hydrogen atom. For suppose if you substitute n equals to 1, then energy of first orbit in hydrogen, that will be E1 equals to minus 13.6 electron volt. Now for example, if you substitute n equals to 2, then denominator 2 square, so the resultant value will be minus 3.4 electron volt. So in hydrogen atom second energy state, that energy value will be minus 3.4 electron volt. Next, if we substitute n equals to 3, then third energy state energy value in hydrogen atom, that is minus 1.51. If we substitute n equals to 4, fourth energy state energy value, so that is denominator 4 square, so that is why the value negative as well as less than 1, minus 0.85 electron volt. Now similarly, if you substitute n equals to 5 as well as n equals to 6, you will get the values like this. Now if you observe the energy difference between any two energies, for suppose between 1 and 2, for suppose E2 minus E1, higher energy state minus lower energy state, then that energy difference you will get 10.2, that is minus 3.4 minus of 13.6. So that is why the positive value 10.2 electron volt. Similarly, if you study the energy difference, if you calculate the energy difference between third and second, then you will not get the same. So here the difference is decreased drastically, and now it is only 1.89 electron volt. Similarly, if you identify between 4 and 3, that is much lesser, 0.66 electron volt. Next and the next much more. See here initially between 1 and 2 10 electron volt, so between 6 and 5 it is very much less than 1 electron volt. So all energies in hydrogen atom are not of same difference. So the energy diagram you can draw like this. So the energy difference between first and second is high as compared with the first and second. Next one is small, next one is much small, next one much small. So actually that gap I should give little bit less, but for the visibility just I am showing like this. Actually as compared with 1 and 2, 2 and 3 is much lesser. Okay, so those values if you write, the ground state, that n equals to 1 energy state minus 13.6 electron volt. Similarly second, third, 4, 5, 6 and 7 and so on. So these values. Okay, so n equals to infinity means almost 0. Okay, so here n equals to 6, next further infinity. Okay, next wavelength or wave number, that also we can analyze. Here according to Bohr, from a particular atom, for example hydrogen, so if electron jumps from one energy state to another energy state, one photon will come h mu, so means that is having certain frequency. We can identify the frequency of the energy emitted from the atom, hydrogen atom, that we can identify. So for that, energy of electron in the nth orbit if you consider, so that is general expression, it is not for hydrogen atom in general. Okay, now at last we will conclude by keeping z equals to 1 to applicable to hydrogen atom. So here general expression, for example consider one energy state, let it be n1 energy state. So two different energies I want to take and between these two energy difference I want to calculate. So that is the first one I consider as instead of E1 I am taking N1 to generalize. Similarly N2, so then that energy state instead of N1 instead of N2 N2. So then two expressions we can get. Now the difference in energy is the photon emitted from the atom. For example, N2 is the higher energy state, N1 is the lower energy state. If electron jumps from N2 energy state to N1 energy state, then you will get the difference in energy, that is general E2 minus E1, here En2 minus En1. So the difference we will get like this, delta E equals to those, if you substitute first N2 term, next N1 term. So here in the second term minus and as well as difference between the two energies, so that the minus and minus get cancelled, or minus into minus plus. So then resultant, so if you take z square e power 4 m by 8 epsilon naught square h square, if you take common, the second term 1 by n1 square, the first term minus 1 by n2 square. Now we want wavelength. So for that purpose, first identify the frequency. For that, shift h other side, then here we have h square, so that left side h if you shift towards right, then you will get at a denominator h cube remaining as it is. Now further, instead of mu, we know that velocity of light c equals to mu lambda, that implies mu equals to c by lambda. So now instead of mu, if you substitute c by lambda in the above equation, then c by lambda equals to, so remaining term as it is. Now we want only expression for lambda, or instead of lambda, so we can analyze the same term as 1 by lambda. The 1 by lambda nothing but wave number, so that we can get. Okay, so the c also if you shift towards right, then 1 by lambda equals to z square e power 4 m by 8 epsilon naught square h cube c into 1 by n1 square minus 1 by n2 square. So this is the expression for the wave number in general for any atom. Now further, in this, other than z square, the remaining just in front of the bracket, if you consider separately e power 4 m by 8 epsilon naught square h cube c, all are constants. If you substitute all the values, you will get one value, that is called as Rydberg constant. Just observe carefully, other than z square in front of the bracket, everything is a constant. Why? Because all are constant values. Okay, so try to remember that value. So that is 1.097 into 10 to the power of 7 or 10.97 into 10 to the power of 6 meter inverse. Now if you substitute that r value, then you will get 1 by lambda equals to z square r into 1 by n1 square minus 1 by n2 square. So now further to analyze, to apply to hydrogen atom, write z equals to 1. So for hydrogen atom, z equals to 1. So therefore 1 by lambda equals to r into 1 by n1 square minus 1 by n2 square. So this is the wave number. With it, number of waves per unit length we can get. Thank you.